demo video for the prostate zone segmentation tool developed by Champalimaud Foundation in the context of UCAME. All of the instructions of what I'm about to go here are in the UCAME bio tools, both for the individual image prediction and for the batch image prediction. So if you don't get anything, feel free to reach out, but please confirm that it's not already explained in the bio tools instructions or in the accompanying README for the GitHub repository. Now, firstly, we have to make sure that we have Docker installed and a working GPU card. Now we can do this, we can check Docker is installed, and we can also see we have a working GPU card by running NVIDIA-SMI. We also need to check that we have access to the UCAME Harbor repository. If that's not the case, please get in touch with the people responsible for granting you access. Now, we then need to identify the study path here as -i or _study_path. In my case, it will be this relatively long path here. Keep in mind that with Docker, you have to specify absolute paths when mounting directories. You have the series folder, which is always relative to the study path. And finally, you have the output directory, which is relative to your file system and as an absolute path. Make sure that the output directory is writable by anyone. This is important. UCAME images use a custom user set, and so this requires that the output paths are writable by anyone. You can do this in Unix if you need to with these commands here. Now we can finally run the Docker command. So firstly, we have docker run. We specify the local path and mount it to data/input. We specify the output path, which is a directory I already created, and mount it onto data/output. We assign all GPUs. You can assign however many you want. We always use a single GPU in this tool. And finally, we specify the Docker image name or the path to the image name as specified in Harbor. This is the part that's specific to Docker. Now the part that's specific to our tool specifically is first stating here NNUnet-predict. This is the first argument. It can be either NNUnet-predict or NNUnet-predict batch. We have specified this here and with plentiful instructions on how to actually run it. Then you need to specify the study path, the series folder, and the output path. And finally, you specify that this is a DICOM directory that you want to use. Now we can see how this all goes. I have the command preloaded here, so it's pretty much exactly the same thing. I will click enter now. And as it runs, it produces a number of outputs, which will be useful for debugging in case you're running into some issues and need to get in touch. By any means, you can also access the bio tools for additional clarification on the instructions, and please also try to access the GitHub repository as well, which has plentiful of instructions on how to actually run this without the Docker container. Now that this is done, we see that it's printed a JSON output after the actual prediction. It created a number of prediction masks, both in Nifty format and in DICOM segmentation format, and also it place the input volume on the output folder. Now this is useful because we can actually access it. So the final prediction is here in Nifty and here in DICOM format. And we have everything that we obtained here. I'm going to open it now. I will start by turning off the interpolation because it's generally not very practical. And I just want to now open the additional image here, the prediction side by side, and we can actually compare both of them and see that there is quite a close match. And this is essentially how you would run this tool on your local device. Now, if you have any questions, feel free to get in touch with myself. Here is my email on the BioTools page. And I hope you have a good time using this tool. Thank you.